We're going to work on an ALEKS problem that deals with using first and second order integrated rate laws. This table summarizes all the important information. So we have the rate law equation for zero order, for first order, and for second order. We also have the units of K. Now the units of K are different depending on the overall order of the reaction. So we have units of K for zero order, first order, and second order. We also have the integrated rate law equation for each of the orders. And for zero order, we're comparing our final concentration to our initial concentration. For first order, we're comparing our final concentration to our initial concentration. And for second order, we have final concentration to initial concentration. So these are the integrated rate law equations for each of these reactions. We also have equations for half-life for each order. Half-life depends on the K, and our K is slightly different for each order of the reaction. So we have half-life for zero order reactions, we have half-life for first order reactions, and we have half-life for second order reactions. So this is a nice table that summarizes all that important information. Let's take a look at an example. In this example, at a certain temperature, the rate of this reaction is second order in H3PO4 with a rate constant of 3.04, 1 over molar times second. Suppose a vessel contains H3PO4 at a concentration of 0.310 molar. Calculate how long it takes for the concentration of H3PO4 to decrease to 0.0403 molar. And they want us to make sure our final answer is in 2 sig figs. So we want to start off always with our given information. It says that this reaction is second order in H3PO4. So I'm going to go ahead and write an equation. Rate equals K times the concentration of H3PO4 to the power of 2. And they give us the rate constant. And it says that the initial concentration is 0.310 molar. And it wants us to calculate how long it takes for the concentration to decrease to a new number. So that would be our final concentration. And we're asked to solve for the time. So we have all the given information that we need. I also want to compare now my final concentration to my initial concentration. And this is a second order reaction. So I'm going to use the integrated rate law for second order reactions, which is this one. So I'm going to go ahead and write that equation out. And now that I have a clean equation, I can start plugging in some numbers. I'm going to get all my constants on one side, my variable on another side. And I'm not going to worry about sig figs to the very last step, so I take it out to a few more digits. I'm going to divide by 3.04 on both sides. I'm going to make sure my final answer is in 2 sig figs. So final answer is 7.1 seconds. So it takes 7.1 seconds to decrease my concentration. Let's take a look at another example. In this example, at a certain temperature, this reaction follows first-order kinetics with a rate constant of 0.0847 per seconds. Suppose a vessel contains HI at a concentration of 0.700 molar. Calculate how long it takes for the concentration of HI to decrease to 20% of its initial value, and they want us to keep our final answer in 2 sig figs. As always, I want to write my given information down. So this reaction follows the first order. So rate equals K times HI to the power of 1. They give us the rate constant. They give us the initial concentration of HI. And they give us the final concentration. They say that the final concentration decreases to 20% of its initial value. So I'm going to multiply my initial concentration by 20%. I'm going to make sure I divide by 100 or move my decimal 2 places to the left. So my final concentration is 0.14 molar, and they want us to solve for T. Okay, I got all my given information. This is a first order reaction, so I'm going to use the integrated rate law for first order. Okay, I got a nice clean equation. Now I'm going to plug in some numbers. I'm going to clean it up a little bit. I'm going to get my constants to one side. And I'm going to divide by negative 0.0847 on both sides. And I'm going to make sure my final answer has 2 sig figs. So it will take 19 seconds for my final concentration to reach 20% of its initial value. So final answer is 19 seconds. Good luck and keep practicing.